right, so up here, we are determining whether A, B, and C, D are parallel, perpendicular, or neither. Notice it says nothing about setting up an equation. So we are just looking at something. In order to tell something is parallel, perpendicular, or neither, what are we really looking at? What are we focusing on? Yes, the slope A. Now, this is one of the things you do not have that formula. So you are, unfortunately, going to have to memorize it. But back in the day, we had to memorize everything. So you guys can remember just a little bit of formulas that you need to. So what is the slope formula that you have to know and have to memorize? Laura, thanks for raising your hand. y2 minus y1 over x2 minus x1. That minus is key. That'll come into play a little bit later here. Now, let's go ahead and label it. We're talking A, B, and C, D. Let's see where they're at. Hey, good news for us. They are in order here. So I will call this x1, call this y1, x2, y2. I have a student ask me, he said, Mr. Carr, do I have to label those? Technically, no, but it's going to be a very good idea to keep yourself organized. So that's going to keep it so organized, so when I plug in the formula, I will be correct. Let's go ahead and start plugging things in. What is my y2 value? 12. Again, I labeled it. You see where it is. It's 12. Always, 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 you hear me, microphone? Always, you're going to put that minus right behind it. Because the formula is minus. And then we're going to subtract that y1 value, and that y1 value happens to be, what's my y1 value? Oh, thanks guys, saving me there. All right, x2, I'll do this one for you. It is going to be 8 because I labeled it such. Put that minus right behind it. x1 value is negative 6. Good. Exactly. Yep. We'll get that in a second. But you were exactly right, Colin. We'll change to that. So let's do the top real quick. 12 minus 5 gives me this number. 7 is a good looking number. It is 7. Over. Now, Colin gave us a hint here. When I have minus and negative, what really happens? It turns to positive.
I still don't understand how that happens.
You don't know how that happens. When I minus a negative, it's kind of like a double negative. Two negatives turn into a positive.
I don't understand. I just do it.
You do it. That's what you do. That's it. Because you're minusing a negative is really undoes itself. It's like cancels itself out.
Yeah, but like 8's bigger than 6, so like.
But I'm minusing a negative. Just like when I add a negative, it's really subtracting.
It's like It's like
It does it.
It's like you're like.
They cancel themselves out, essentially, what's happening. They kind of undo one another.
Away, so like.
They're taking away the negative. You want to think of it that way. So when I turn it to positive, it's going to be 8 plus 6 gives me a 14. Good. Does that look good? That's right, but is that simplify? Every time we have a fraction, we need to simplify. 7 over 14 gives me this new simplified fraction. 1/2. Very good. And again, graphic calculator, folks, you could have typed this in right away. You would have got your answer reduced all the way. All right, so that's one of my slopes. Again, I have another segment I'm going to look at here in a second. Well, let's pretend for a second. I'm going to do some guesses what's going to happen. If I solve CD here in a second, what would the slope look like if it was parallel? What would the slope be if they were parallel? 1/2, right? It would be half. So if I solve CD and get a half, guess what? They're parallel. What would it look like if it was perpendicular? 2 over 1, I agree, but something else? Negative. The signs have to change. One has to be positive, one has to be negative. So perpendicular, we look at a negative 2 over 1, or just a negative 2. And then neither, it wouldn't fit any of those categories. They're not exactly the same. One, they're both negative. They're not exactly the same. Something else other than that. Well, let's see what we got here. We know what we're guessing. Let's see what we have. Again, label these points again. x1, y1, x2, y2. Plug it into our old formula. The formula up there in black that you have to memorize. So I'm going to go with a y2 gives me a 20. Put that minus behind there. My y1 value is 10. Over. Now let's look at those x's. So I got an x2 value of 3 minus x1 value of negative 2. There's that minus and negative again. I think we know what's going to happen by now. 20 minus 10 gives me this number. 10. Yeah, real easy there. And 3 minus negative 2, that turns into a positive. 3 plus 2 is a 5. See? 10 over 5 does reduce. And it reduces into 2 over 1 or 2. Good. All right, look at these slopes. You just put 2, that is acceptable as well. Either way. 4, 2. So, are these parallel, perpendicular, neither? Neither. They're a flip fraction. They're not opposites. Means one's positive, one's negative. So if they are not exactly the same, I mean, if they have the same sign, this will be a neither. They have the same sign and they're not identical, meaning the numbers are the same, it will be a neither. Questions with those? Okay. Let's try number, letter 2 over here. Letter 2. All right, let's go through, do the same thing. All right, I got this. So this is going to be my x1. Oh, I want that color. I want blue. This is x1, y1, x2, y2, right? That's good. That's good. Why is that wrong? Oh. Oh, I did it because they're the first two, and I assumed that AB was the first two. See what happens when you assume? Makes you look silly. So that's not correct. So I'm going with A and B first. So A is all the way at the back, so this really is my x2 and y2. But we're still using that same exact formula. So let's go ahead and use it. Well, we plug it into the formula just like we did a second ago. Y2 again is at 16 minus my y1 value of, no way, over.
Negatives as the opposite of, like, says if it was plus -6, it'll be plus the opposite.
However you want to think about it, yep, they kind of undo each other, opposites, the same thing. Put that minus right behind there. And again, it happens again. It's a -4. Equals, we need to reduce our fraction. 16 minus 9 is? 7. Hey, like that one over there. We figured that out earlier. Just like before, we found out they're undoing one another. They cancel each other out. However you want to imagine it. 3 plus 4 gives me this number. 7. Yes, Jason? Well, let's get through this real quick here if we can. We'll do his notes and then we can go here. So, 7 over 7 does give you a 1, because anything divided by itself is 1. Great. Well, let's go ahead and look at CD. So this is x1, y1, x2, y2. What do you say? You could do it that, it doesn't matter. I just want to stay consistent. Yeah, I know what you're saying, because I should say D, it doesn't matter. Because when I plug it in the formula, no matter which way you do it, because of this formula, the negative, it will stay the same. Doesn't matter a word. Doesn't matter.
You're sure?
I know. Yep, doesn't matter. As long as these two are consistent, meaning that's x1, y1, x2, y2, it doesn't matter. It'll be fine. I could have done D, C, C, D. I could have done A, B. As long as these guys stay consistent with one another and these guys stay consistent with one another, then you'll be fine. All right, let's go ahead and do so. We're talking about CD now. Back to that same formula. Y2 is a -4 minus, put that there. Y1 is 11 over. X2 is a -8 minus 7. -4 minus 11. Negative what? It is a -15. Get a pause in there somewhere. -8 minus 7. Again, they're both negative, so they will be negative again. What's 8 plus 7? 15. What? What's -15 over -15? Positive 1, because a negative divided by negative, same concept, is a 1. All right, let's look at these slopes. What do you notice about these slopes? Parallel, what? They're exactly the same, so guess what? They are parallel. Boom. Good. Good. Questions with analyzing slope between 2 points?
Okay,
Memorize that formula. You're good.
I get it now. Before when I didn't understand what I was trying to do the problems, I was like, what I was doing is that I was basically looking at the different points and like trying to like put them on a mental grid, which was kind of hard.
It definitely is going to be hard. The easiest thing is to use that formula and just plug it in. And again, practice is key on that one. And guess what? More practice coming at you. But now we're talking about this one. Still building on that concept, but let's go.
Point 3 says determine the equation of a line that is perpendicular to y equals 1/5 x plus 9 and passes through the point 2, 6. So whenever you see this word perpendicular, what do you know you have to do with the slope? Good. Flip the fraction, so flip it. And change the sign. Very good. So what's the slope in that equation? Well, before we go through the process, what's the slope in this equation?
The original one.
Of the original. This guy. What's the slope of that one? 1/5. Okay? 1/5. So then, exactly as Grace did it, when we flip it, what does that give us? Flip it, and it gives us 5/1, and then good, we change the sign, so it becomes negative. Flip it, change the sign. What's negative 5/1 reduced down to? It's negative 5. You watch this negative 5/1, not the end of the world. Right? So that's our new slope. Is negative 5. We want to write a new equation in y equals mx plus b form using the slope negative 5. Here's the thing. Did they give us our b? Did they give us the b of the new equation? No, they gave us the b in the original. That's not important. We don't care about that one. Alright, we're not going to use that. Time to take a move. No. Okay. So we have to figure out what b is. How are we going to figure out what b is? What can we do with this point? Plug in x and y. If it helps label, the first term is x, the second one is y, and plug them in. So 6 is going to go here, negative 5 is going to go in for m, and 2 is going to go in for x. And again, we have no idea what b is, that's what we're solving for. So then solve. What's negative 5 times 2? Negative 10. To get b by itself, what do we have to do with the negative 10? Got it. So b ends up equaling what? 16. So now we have our b, we have our m, what's the equation of this line going to look like? Y equals you just take your m, plug it in, take your b, plug it in, that stays an x, that stays a y. And there's your answer. I did a really good job of getting to this point. You boxed up b and called it a day. You have to make sure it asks for an equation of a line. Write the equation. Okay, questions over there? So, determine the equation of a line that is parallel to the line y equals negative 3x minus 8.
I missed the very, very last part.
What do we know about the slopes of parallel lines? They're exactly the same. So whenever you see the word parallel, you know it's the same slope. So the slope is not going to change at all. So what's the slope of that original equation? So what's the slope of our new equation going to be? Negative 3. We know this is the slope because it's what's in front of the x. Alright, so then we want to write it in y equals mx plus b form. We know our m is -3. Again, they did not give us our b, so what do we do at that point? Plug it in. And hopefully we'll x and y. -7 goes in for y. -3 goes in for m. 2 goes in for x. And we solve for b. Yes. Where did you go? You're going to miss your review.
I think I understand it, and
Use your phone. So when to solve for b, what do we get? -6. -3 times 2 is -6. Want to get b by itself, go ahead and do -6. Done. What's -7 plus 6? We have our b. That does not mean we are done. What do we get? Equation of our line. Put that in there. Plug that in there with their equation.
Alright. Let's go on to the fun part. I like this one. Finding distance. Finding distance. How do you find it? Well, we showed you yesterday, and some of you in your past used it before. I know you did something in Algebra 1. But we have that distance formula. You know, the square root of the x1 minus x2 squared plus y1 minus y2 squared, blah, 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 all that stuff. That's great. But you were not given that formula. If you like that formula, memorize it. Use it. If you do not, then you will do it our way that will show you. Because again, you always have graph paper, and you guys have points. You're able to graph those. And that's what we're going to do. Because we are going to use the Pythagorean theorem to help us solve for this unknown side. Why? Because we're making right triangles. So the first thing first is you have to know that Pythagorean theorem. The nice thing is it's given to you on your reference sheet. But since we don't have that, can someone remind me what the Pythagorean theorem is? Jacob, what do we got? That is correct, Amunde. A squared plus b squared equals c squared. Again, that's what we're going to be using to solve. Well, now that we know that's the formula, let's go ahead and plot our points and try to make that right triangle. When I go through, 10, -7, right there. Next one is -5, 1, right there. And I'm going to connect that dot. That's the segment I'm trying to figure out how long it is. Problem? I don't want to use that formula. I don't have it. So I'm going to make a right triangle. Again, it doesn't matter where you draw the right triangle. I just want to make sure that when I do it, I'm doing it on straight lines, no diagonals. So I'm going to go in here. I'm going to go down to this one. I'm going to go over this guy. I made that right triangle. If you made yours on top, that's fine. Make it on top. It doesn't matter. We're still got the same distances. And remember, since I made a triangle, I know a lot of, like I said, some students get this mixed up with slope. You say, well, how do I go from here to here? I go down. I go a negative distance. No, sides and segments are always positive. So let's count positively. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units there. How far is the other way? Let's figure it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, lost my breath there a second. 15. The nice thing about the Pythagorean theorem is it's always the same because that distance, that piece I'm trying to find, will be the c value. So a and b, again, don't matter. We just plug it into that blue formula at the top. So I'm going to go ahead and say that 8 squared plus 15 squared is, in fact, equal to c squared. Let's do some simplification to figure out what we get. 8 squared is? 8 times 8 is? 64. Plus 15 squared is? 2, 2, 5 is equal to c squared. We are going to combine these together. 64, 225 gives me this number. It's a 2. 8, 9 equals c squared. How do you want? Leah, yes. Said no. I'm not answering. So, how do you want to do a square? Square root. Root is on par. Is 289 a perfect square? Is it? Oh, okay, good. What is it? Equals 17. Hey, what if I told you that I knew it was 17 without doing any work? What if I told you that? Would that be cool? Because it is, in fact, a p-trip. It's a whole number. It's the right triangle. But this is the third or fourth Pythagorean triple we showed you. This is an 8, 15, 17 triangle. You have the 3, 4, 5. Then we said the 5, 12, 13. And the 8, 15, 17 is another one.
How is that?
How is that?
I wasn't there.
You weren't there for the p-trips.
No, I really wasn't.
That's fine. Then you just do Pythagorean theorem and that's it. It's just there's certain ones that are always right triangles. We call them Pythagorean triples. They're ones that always work. That's good. That's a good one. That's an easy one. That's what most of them are. But there are other ones out there that exist. There's many of them. Infinity of them, actually. But you have to remember them. And just remember the small ones.
5, 6.
No. The only one that goes to row is 3, 4, 5. The other ones, the next one after that is 5, 12, 13. The next one after that is 8, 15, 17. The 6, 8, 10. There's many more of them. But there it is. Again, if you need to recognize it's a Pythagorean triple, Pythagorean theorem won't fail you. Alright, C is 17 units. Good. Questions with that? Let's make another triangle. Why not? We're in the triangle mood. Holidays are coming up. Let's make triangles. So next one. 6, negative 3. Got it. Wait. Oh, okay, yeah. I feel like you did this one. 6, negative 3. Right there. Negative 2, negative 5. And I connect that segment. And that's the segment I'm looking at. Okay. Well, last time I went up, so let's make my triangle on the bottom now, I guess. So I'm going to go over. Oh, come on. Come on. I'm going to go over and up. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Oh, unfortunately, 2 is not an acceptable sign of the Pythagorean triple. So that means that we're probably going to have to rationalize this, reduce this radical a little bit here. But no big deal. We'll go ahead and solve it anyways. That side we're looking for is C. Take those two legs, plug them in. 2 squared plus 8 squared is still equal to that C squared. Calculators out, 2 squared is? It is. Oh my goodness, thanks guys. Thanks. 8 squared is? We had that a second ago, you better have said that. Equals that. Combinify those two guys together. 4 and 64 gives me 68. Nice. C squared. And we know we're going to square root to get C by itself. Square root, square root. Is 68 a perfect square? Did that guy say no? I feel like he just said no. He knows. Did anyone hear that?
Definitely said no.
I feel like he did. Did you hear him?
No, he did.
I swear he did. He did. He said no. So he's listening to our lesson right now. But is it square root of 68 is a perfect square? It is not. 64 is. 81 is. It's in between that range. So it's not. It's not going to work out. So then we have to factor this out. We got to think of what other two perfect squares. Give me the largest perfect square that goes into it. Let's see. 4 and 17 is correct. 4 is the largest one that goes into it. So now we can have our answer. Get what it is. C equals. What's the square root of 4? 2. What's the square root of 17? Doesn't work. So it's square root of 17. Have it. Yes. Huh? Okay, well, good job, raise your hand. Questions on that? I like this one. Pythagorean theorem, it's a lot easier to use the distance formula. So, now let's go on to the next concept. That concept of midpoint. It's a point in the middle.
What we talked about yesterday, we are trying to find the midpoint of the segment CD, which is a point directly in the middle. It has endpoints of 4, 8 and negative 5, 6. To find the midpoint, think you're finding the average. Okay, so you're finding the middle. What did we say yesterday to do with the x values? We're finding the midpoint. You add them, good. So we're going to add our x values. And then what do we divide by? You find the average, divide by how many things you added. 2. You just add the x values, divide by 2. Add the y values, divide by 2. All you have to do when you find the midpoint. Add the x's, divide by 2. Add the y's, divide by 2. Every time it's just different numbers. So what do we get when we do 4 plus negative 5? Negative 1. By 2. And then 8 plus 6? Is what? Divide by 2. What do we get when you divide these by 2? Is that already simplified? Yeah, so negative 1/2. Can't do anything else. So they do as negative 0.5. That's totally fine. What is 14 divided by 2? 7. So the midpoint is directly in the middle, and that is negative 1/2, 7. So if we were to plot these endpoints and plot negative 1/2, 7, it'd be right in the middle. Again, when you're told to find the endpoints, if you want to make a note, add x's, divide by 2, and then you add y, divide by 2. That is the process for finding the midpoint. Questions over any of that?